Today's presenter is myself, Dan Giordano, the product marketing for ReadyAPI and our API products, and then Russell Viola, our solutions engineer for ReadyAPI. We'll be getting to our demo at the end, and we'll be running through some REST testing with the actual ReadyAPI product and SoapUI tool. All right, so quick housekeeping. This class is going to be recorded. If you have any questions, just throw them in the Q&A box. It's a lot easier to handle in the Q&A. If it is real pertinent and I can jump to it, we'll answer as we go. But if not, I will get to all the questions at the end of today's session. And then I believe we have an exit survey, so please answer the exit survey as we leave the webinar today. All right, so intro to SmartBear. SmartBear tools are synonymous with quality across the entire SDLC, from planning and designing and testing and monitoring. We were founded in 2009 in Boston, Massachusetts, and have grown to over 11 global offices encompassing North America, Europe, Asia, and Australia. Over 6 million developers, testers, and operations professionals from 20,000 plus companies like Google, Sonic, and RBC use our tools every day to deliver bug-free software. Our company of over 500 employees also provides 5 free tools for the community, including 2 wildly popular open source tools, Swagger and SoapUI. We were just recently placed in the Gartner Magic Quadrant for 2018 inside software test automation. You can see us there at the head of the pack, leading for our ability to execute across enterprise organizations. And we have a deep portfolio. We have design, creation, testing, and monitoring tools, and then we closely integrate in the deploy phase with partners like AWS, Chef, Maven, all these different tools that are there in that space. But we have design and planning tools like HipTest, Swagger Hub, and Zephyr. Then creation tools for the build cycles like Service V Pro, Collaborator, and Test Left. Testing tools for proper QA organizations like SoapUI Pro, Test Complete, CBT, with performance tools, LoadUI Pro and Load Ninja. LoadUI Pro we might take a quick look at today, but it's part of our ReadyAPI suite. And then lastly, once we're in production, we're able to monitor with AlertSite. Today's agenda, we'll be going over the basics of APIs, the REST basics as well, testing APIs and how that's special. We'll go over a quick end-to-end API testing example as well, and then we'll hop right to a demo. We'll talk about a little bit about shifting left as well. All right, so all applications have interfaces. These, we can think of them as layers that talk to each other. The top here, we start with a database layer. This is usually the bottom layer that holds the information or maybe the functions that we're going to use. The API layer is this middle piece that we'll be talking about today, and how it's grown across enterprise organizations and architecture in general, especially from web, but also how it has come to the forefront as a product itself. But that API layer today is handling logic. In this case, like when X SKU returns X price at Y discount, it can handle all of that for us, grabbing from the database. And then the UI layer sits on top of that, and that's that visual or graphic user interface that most customers interact with. But that API is that intermediary piece of software that allows one piece of software's data or functionality to talk to another piece of software or the application. An example of a famous API might be the Google Maps API, which lets services like Uber or Seamless use their navigation system, while those companies can still focus on being either the best ride-hailing app or best food delivery service. You can think about it in context of building a home. The same company that builds roof tiles probably doesn't also build a garage door. Our world is becoming super specialized with garage door makers who have made hundreds of thousands of doors in the process and perfected it. We're now in that phase as well with software and APIs. Companies are specializing in certain functions like either location services like we talked about with Google Maps, messaging services maybe with a Twilio, or even a payment service like Stripe. Because APIs are beneath the UI, they have inherent advantages in both the development and testing cycles that we'll encounter today and we'll go through. Just a quick level set. This is the UI, right? The UI of a website. This is Best Buy example, Fitbit Versa Peach Rose Gold. It has objects on it, and they're all actually derived directly from an API. In this case, we can see here the product title, Fitbit Versa. It's displayed in our UI. But if we look here at this RESTful API response, that same information is available to us. And this is what would be an endpoint response. This is actually in a browser. Because RESTful APIs interact over HTTP, they can still work, which we'll go through a little bit. But this is, again, it's the same information. It's more machine readable than that UI before. Let's say something moves around in this clip. Let's say we actually remove something. That might change up different parts of our testing or development because we were focused on coordinates of the screen or visual impact or visual aspects that we actually impacted. Again, when we have this JSON response here, this machine readable flow, we're going to be a lot more exact in both our development and our testing. And it's important to remember that there's multiple APIs under the hood of most applications. In this example, we just have a few that we're showing. There are APIs that are going to fetch product summaries. There are APIs that are going to find pickup locations that are then connected to APIs like the Google Maps API, and they're actually giving each other information on the fly there to then pipe into the UI. We also have account logins. Again, here are places where we're integrating with third-party APIs like maybe Facebook or Twitter to actually handle that logging in and storing of that data for us. And then lastly, in the bottom right here is a quick pricing API. All these different APIs work together to serve that central UI here, in this case, when we go to bestbuy.com. Quick flip to talk about particular APIs themselves. These are the two main categories we have today, although there are kind of growing space. REST versus SOAP, you'll hear this a lot, and it's technically the wrong conversation to be having. There are going to be a lot of caveats here we go through. But the main difference between SOAP and REST is the degree of the coupling between the client and the server implementation. So REST is a lot more free forming. We can think of it more like a browser. It's like a generic client that knows how to use protocol and standardized methods and has an application that fits into it. The stateless application on the right or on the left here, sorry, REST, that communicates via text, JSON, RDF, XML, one or two, I think, communication layers that it can still talk over. But it's a much more free-floating type of application. SOAP, on the other hand, we can think of almost as a desktop application that's tightly coupled to the server and not just the client. There's a really rigid contract between what's happening on the client side and what's happening on the server side. And everything expected to break if either side changes. So it kind of has the advantage of coming out of the box more secure than REST. And that's really one of the main advantages over in the enterprise world is security. When we're talking about REST over the HTTP protocol, all security measures applied to that HTTP call are inherited. So REST itself doesn't have any exact security behind it. It's really just the protocol it's going over. And this is known as transport level security. It only secures the message while it's inside the wire. So it's while it's happening over that HTTP protocol. But once it's on the other side, there's nothing to really make that secure validation and make sure that our data, the way we wanted it to, actually got there on the other side. SOAP, on the other hand, not only does it support SSL over HTTP, so you're going to get the same level of transport level security, but it also supports some more enterprise security features like WS security, which is going to offer protection from the creation of the message to its actual consumption. So it's not just transport level, but it's going to be, it's going to fill in that loophole from when the data actually gets on the other side. We're going to be able to validate actually that contract. Today, we're going to be talking mostly about REST. It's by far more popular today for modern web applications. And one beautiful thing about REST is that it's really clean and easy to use. Here are 4 main actions we can take with the REST API. The first one is get. That's going to allow us to retrieve data. If we were to simply go look at a website, that would be a get call, like Best Buy. It would give us a list of maybe items or something we wanted to look for. Post. Post is adding new data to the database. So let's say we had access to Best Buy's products database, we'd be able to post new items into it. A put is actually updating data that already exists. So once I added my new item to the database and I wanted to change a name or change the image, it would be a put command and not just a post, so I wouldn't rewrite over it. And then lastly, it's delete, which obviously removes data from the database. It does exactly what it says. But all these instructions, these action words right here, really level set the entire interaction you have between services, because it makes everything finite, it makes everything standard, and a very clean implementation of a complicated integration. A request example on the left here is our famous pet store Swagger example, and we're going to look for, this is a method type get, and we're going to look for pets with the status of active. So we can see here, right here, it's very clean and legible. We have v2/pet, and then we're finding by status, and we're giving that parameter there, status equals active. There's a couple of request headers here, like we're asking, we're keeping our connection alive. We have our host, so that's going to give us a little bit of security while we make that call. And then we have optional request body, which there's nothing filled in here, but you could have something. Once that request is made, it's going to return a response. And the response here on the right is an example of just an available pet that we have. So you can see in the bottom response body, we have ID of 1045 and category dogs. So this is an example of something we would get back from that request. There are also response headers that give us a little bit of instruction as well for maybe the content response type, or again, the access control methods we talked about before, like get, post, delete, and put. These things can confine the way we interact with the data itself. This is a real brief overview and kind of glossary of some of the finer points, some more technical aspects of that REST endpoint. We have the endpoint itself in the top left, petstore.swagger.io. There's versioning there, so we can see Spotify is on version 1. This Swagger spec is on version 2. And then we have our calls themselves, so pet, and then find by status. Below that is our request query parameters. So we're looking for the ID of 3012 or category animal. Request headers, again, these are going to be ways we can confine the request itself and what we want back from the response. And then our request body. And then on the right is basically a mirror of that, where we have a response status code. So this is just like we have in the web. So you would get a 200 OK, or maybe a 404 if you were to go to a wrong website and they have a response for you, maybe a search bar so you can find something else. APIs are going to work the same way, where we're going to have those same responses. So now let's talk about a little bit of testing and where APIs come in. Test automation, a base layer of API and UI, is the future of software testing. Both Gartner and Forrester predict that by 2020, nearly 90% of all testing will be automated, with exploratory being the last 10% and really always a necessary function of any application development. But other than that, automated API and UI testing is set to grow exponentially in the next 5-10 years. You can see here that API testing is even set to grow at a more astonishing rate than that of UI testing. And that's because of not only the growth of the APIs in general, but also because there are inherent advantages to testing the API layer itself. And we'll visually kind of walk through these advantages, but it all starts here with microservices and the transformation from monolithic applications to microservice architecture. So here, example of 2 applications that are sitting on top of a database, 2 examples of monolithic applications, where the UI layer, represented here in this blue box, is inherently tied to the service layer. So our payment service, our login service, our product service, our pricing service, all these are tightly coupled to logic and UI, and they go retrieve things from one database. So if anything were here to change, we'd have to change the entire application. If any testing happens, it's going to happen at a ginormous kind of monolithic big box that we're going to test this outside of and hope that anything that happens inside we can fix. But with microservices, we really break this apart. And this is the way really all architecture is trending. And you can see now, instead of having 2 services to test and scale, actually, we can scale horizontally, and there's multiple services to test here. And this is just a quick example of the kind of UI versus API and also monolithic versus microservices. If a test fails when we test this app right here, we have to track down what exactly was happening during that testing step that broke. So if we're going to find our product, it might have 12 connections in the background that we'll look through in our demo in our built-in API discovery browser, but there might be services back there happening. So 12 things happen between step 1 and step 2. And then from step 2 to step 3, actually 10 connections happen, and wouldn't you know it, one of them broke. But we're not really able to tell which one broke. So we're just going to be able to toss over to our development team and say, hey, step 3 here, we weren't able to actually purchase the watch. So there must be something in your code base that is broken. With microservice and API testing, if a test fails while testing each connection in between the microservices, we know exactly what caused the failure. So not only would we be looking at the UI, but we'd know exactly that maybe, hey, the payment API couldn't update to the pricing API, so it failed. So those multiple connections in between those big end-to-end UI steps were now easily fixable because we're actually testing that unique layer, that specific point. And here's just another example of end-to-end testing on the API side. It looks very familiar if you're used to doing it on the UI layer. It's going to be very similar, where we're walking through these steps. If we send the name here, that's going to go to, what are we looking at here? Yep, sorry about that. We're going to send a name of a product, and that name is going to hit our API and then ask the database and say, hey, what's the SKU for this name? The name API is going to send back the SKU to the ReadyAPI client or the browser or the web application that's using this API. And then that will store and send information, that SKU, to a pricing API. Then that pricing API will go ask the pricing database for price, and then it will return it to ReadyAPI. But all these things are happening through multiple API layers, and we can think of the end-to-end testing flow very similar to the end-to-end testing maybe that's happening on the UI side that you might be more familiar with. Just to wrap up some quick advantages of API testing and an overview of this, the first one here is the immediate testing of business logic. So we don't have to wait late in the sprint to have our entire application get compiled or multiple teams' work actually finish. We can actually create API tests with our very first piece of API definition or code we lay down. It's going to happen very early in the process. So if we start our sprint on Monday, maybe by Tuesday or Wednesday, we actually have our first tests written. Or if we are part of a TDD or BDD shop, those test cases might be written before, and they can really be run very, very quickly. So we don't have to wait late to catch bugs. Next is API tests are far less brittle and easier to maintain. So generally on the UI side, you'll have elements that move around, HTML, CSS, browsers. They actually look and compile all of those differently. With an API, it's going to move around a lot less. There's no colors, there's no sizes, there's no cosmetic characteristics that might throw a test off. There's also definitions many times. So whether you're using an open API specification or a WSDL on a SOAP call, that definition really informs what's happening on the API layer. So any changes made there can propagate throughout our testing. We also have faster test execution on the API side. This is something that's near and dear to SmartBear's heart because we are obviously a large testing company, and we do have solutions that really can crank through UI testing. But in general, UI tests still are going to be much, much longer than the API side. If a UI test takes 3 minutes to run through a login, maybe exercise, that API test that was testing those same 3 connections, they might run in 3 seconds each. So it's much, much faster test execution. We can run more in less time and really increase our coverage. And then lastly is our faster root cause analysis. So when an API fails, our time to track down what happened is significantly less than the UI side. We're going to have a much quicker mean time to resolution, and we're actually going to be able to tell our development team what happened, where it happened, and how exactly they should fix that. So before we turn to the demo and we actually look at SoapUI, I'd like to take a little bit of a look at the platform itself. So the ReadyAPI platform consists of 3 different modules. The first is SoapUI Pro, which is for functional and security testing. The second is for LoadUI Pro, which is for load and performance testing. And lastly, we have Service V Pro, which is for API and service and UI virtualization. These all go together and they're all in one interface with ReadyAPI, and they sit on top of an ecosystem of integrations with such tools like Jenkins, TeamCity, Azure DevOps or Azure Pipelines now, Git, Slack, and more. And lastly, before we turn, I just want to show a quick visual as well of ReadyAPI and API testing getting used inside of a CI/CD pipeline. So right after our developers commit our tests or new code, we can deploy that service. We can package it up, deploy it into, let's say, a Docker container or whatever infrastructure you're using. And then we can launch SoapUI Pro, LoadUI Pro, and many aspects of ReadyAPI into our CI pipeline to test. That can be done either with native integrations or the command line tool that we'll look through. All right, so now we are going to turn to Russell, and we'll be looking at actually the tool itself. Let me pause my sharing.
Hey, thanks, Dan. We're actually waiting just a second here. I don't have the ability to share my screen, so I'm going to have to just rework how I come into this meeting here. My apologies.
Sorry about that. 1 minute, folks.
So let's here, folks. All right. Apologies for the inconvenience. Again, my name is Russell Viola, Solutions Engineer here at SmartBear. I want to thank Dan for the intro, getting us familiar with API testing and what it means nowadays and how important it is, really. So, you know, now that we know some of those basics, we can start to look at ReadyAPI, how that's going to really facilitate this process, which can sometimes be a little bit daunting in testing that API layer of our applications or our infrastructure. And today we're mostly going to be looking at SoapUI Pro for that, because it's a great place to start. And you'll notice that it's actually one of a few products here within ReadyAPI. So we have SoapUI for our functional testing here, again, which we'll be looking at in more depth today. Along with that, We have Secure Pro, which is actually paired with the SoapUI Pro license. That's going to allow us to do some pre-built security scans against our responses to check for vulnerabilities. We have LoadUI Pro, which is our load and performance testing tool. Essentially, we'll take functional tests we create in SoapUI Pro, use those as scenarios in LoadUI Pro, and start to apply scale to them, and put our application up against the limits to really see, how it handles this scalability, and look out for bottlenecks and things like that using the tools within LoadUI. And then there's Service V, which is our virtualization and mocking tool. So we can take definitions that we've either built within SoapUI or imported and start to create virtual services with real life logic that are going to behave like real APIs depending on how we configure them. And we'll even be able to, say, record third-party APIs, right, to kind of eliminate either the monetary or the time bottleneck that comes with working with those, and then be able to share these with our team outside of a local environment, so that even folks not using ReadyAPI are going to be able to interact with these. So we can supply these to our devs, we can supply these to our UI developers, etc. And what really ties these all together within ReadyAPI is that we are working off from a centralized location here. And we have this projects tab where we do things like handle authentication. We would refactor our definitions. Say we made some changes to our API definition. If we bring that in, since we're working from the centralized definition here, when we make changes to our API, those are going to persist throughout the suite, right? So say I make changes to the structure of a request, that's going to reflect in SoapUI. If that SoapUI test then being used in LoadUI as a functional test, I won't have to go into LoadUI to change it, since it's working off of this project, right? It's dependent on that. So all those changes persist throughout. And that's how we really streamline that end-to-end process here in ReadyAPI. But again, that's a lot to go over in one session. So the best place to start is with SoapUI Pro and start this functional testing out. So when we get to that part, we'll now we're thinking about how exactly we're going to get started with our testing. So there's a couple ways to bring things in to SoapUI. I'll start by showing this our Explorer here, our REST discovery, where we can use a built-in or external browser essentially to browse over these endpoints. And we'll do something like, we'll do bestbuy.com. Since we've been using this as an example thus far, it's a great visual representation. And we'll see already that, I mean, we're recording tons of transactions here because there's a lot of APIs going on here. There's a lot of services going on. And we're going to be able to, generate some transactions, navigate the site as a user would, right? Let's say, Mario Brothers, sweet. Let's check it out. We can record those transactions. We can pause now and start to filter through these, right? So let's see, I want anything that's interacting with API. I can come in, select some specific services here, maybe. We have some product summary and price carousel, and generate services based off these actually to get started testing. And this is just one of the ways we have here, but it's great to come take a look at it. We'll have a lot of example information to work with, so we'll essentially have this boilerplate to get started and make some repeatable, reusable tests from. And using this outline tab, actually, which we'll use again throughout this demo, rather than interact with XML, JSON, or even the raw data that we get back, we're going to have the ability to interact directly with our responses now within SoapUI Pro and make assertions and validations directly against them, which helps us to avoid scripting Some folks are familiar with it, some folks aren't. This really eliminates the need to parse through these large data objects that we get back with any form of scripting, right? We have our JSON path expression, so we know where to look when we're testing this, and then we'll set our expectations within this assertion. And this theme of kind of parsing through large data objects is pretty prevalent throughout our workflow today, and we'll see it in a couple different places because it's one of the biggest time savers about using SoapUI Pro is that we can visualize these things rather than, referring to scripts and parsing data objects and logs and things like that. So, this is grabbing information from a website that we can actually access, right? This application has a face, for instance. But in a lot of cases, especially with microservices, we may have two applications communicating with each other, right? There's not going to be a user interface where we necessarily browse over. It's going to be much more efficient to create our test cases in a different way than using a browser. And in that case, we have the option to either bring in an API definition. If we're using WSDL or Waddle or Swagger, we can directly link to those. And this is a really quick way to get started. We'll kind of take a look at that as well here. We can add to an existing or a new project. And what we get here when we start this, and you'll see it again when we do a URL, is these automatic validations out of the box. So we'll always get valid HTTP status codes and response SLA assertion, whether it's URLs or definitions. What we get when we bring in definitions extra is this schema compliance assertion. And these are three essential assertions we're pretty much always going to need. So right out of the box, we have three pass-fail validations that we're going to be able to use to get starting testing right away. And you'll see here, I mean, this definition isn't enormous, but it's quite large. And we're already running tests and we're getting feedback within about 30 seconds of bringing in this definition. Now, I want to kind of break it down even more and simplify it because if we're not working with definitions, we'll have some URLs and some endpoints. And there's two ways to do that here. We can take a look at our Endpoint Explorer here, which is simply just going to allow us to construct an API request, right, in its URI format. We can put together posts, we can put in bodies and payloads if we need to, things like that, and just send it against the API and double check that we're getting exactly what we want before we commit to creating a test case. So this will allow us to explore a little bit, make sure we're hitting the right things, and get started from there. Alternatively, we'd be able to add multiple URLs with all different methods, right, and kind of build that internal definition that way. But for the sake of simplicity, so we can really look at data-driven testing in a simplified way here, we'll stick with the Google Maps call, and we'll just do one and start to drive data through it and look at how we can pass data around the tool. So I'll add this to a new project. We'll get those two assertions out of the box here, and we'll be able to get started. So that was all the different ways we can bring our APIs in to get started, right? We used REST discovery in this case to go over a full application like Best Buy, for instance, grab the specific calls that we want to be testing and start from there. We brought in a definition and all that comes with that while applying some schema validation on top of our regular assertions. And we also use this Endpoint Explorer to double check our URI, make sure we're sending the right information, getting the right information back, and using that to start our tests. Now, once we're here, we can talk a little bit more about our request editor and what we can do in here. We have our request window and our response window, and we took a look at the response window a little bit, where we saw our XML or JSON our raw data and this outline tab, more importantly, right? Because this is where we're going to make most of our assertions. Our request window is pretty similar, right? We have our raw data. Depending on the type of request we're sending, we'll have outline or form. And if we're sending a post, we'll have access to our payload in a bottom window here. We can add assertions from the assertions menu if we'd like to, if we want to make those validations against our API, because it's important that we build these out to a certain level of specificity. That way we're going to detect when things are going wrong in this API layer that might not be apparent during some UI testing. And we can set up things like property content assertions, compliance and standard assertions that we might not have yet. We can even script those out using the Groovy language and an internal Groovy editor within SoapUI, which is going to allow us things like auto-completion, using outside libraries, maybe for those more complex assertions. If we can't find it in the box here, we'll be able to script it out. The other way, which we already kind of touched on about adding assertions, is by using this outline tab. And again, the benefit here is that I can directly interact with the node here and make an assertion without parsing through this data object. No, we don't have to script to do this. We'll get this JSON path or XPath expression depending on our response. And then we can set up these validations quickly and start to prepare ourselves to get better feedback during our testing. So as it stands now, we have a couple validations in place. We're making a single API call. Some of these values are still hard-coded. And we're not really leveraging all that SoapUI Pro, specifically within ReadyAPI API suite, has to offer. And what we can do now to bring this beyond a kind of simple unit test request and response with a few validations is use the ability to data drive our tests. And then from there, get reports and then further automate it so that once we've configured these tests, until there are some significant changes that we can't solve by refactoring, we won't necessarily have to come back into the tool to run the tests and get the feedback that we want. So the first step is to make this reusable. And essentially, we're going to eliminate these hard-coded values and start to put in dynamic variables with a tool called get data. And in order to have something to grab, we need to pull in from a data source. So among many other steps within the SoapUI Pro toolkit, we're going to be using data source and data source loop today. And we can create one of these automatically, but I'm going to show you some of the options that we have to actually use as a data source. So we'll skip that wizard for now, although it is there as an option if we'd like to in the future. So let's talk about this data sources here. We have some options as far as what we bring in goes. We can bring in something like an Excel file that might have been prepared earlier or is being generated and amended, right? We can bring in CSV files. We'll be able to directly make JDBC connections with our SQL databases, for instance. We can randomly generate data as well, right? SoapUI has a number of formats that we're going to be able to generate just from within the tool if we'd like something random. And in this instance, we can do something like city. And what we'll do here, before we generate these 10 cities that we want to test, we are going to assign this value to a property. And what this property is essentially SoapUI's way of assigning these dynamic pathways that we're going to grab when we're making this reusable test. And we'll see a visual example of this in just a moment. So let's generate 10 cities here. Make sure we've got the right thing going on here. Looks like we've got some cities indeed. Great. And obviously, these data sets can get more complex. In the case that we're bringing SQL databases or Excel files, we're going to have multiple columns. And no matter how we bring it in, we're going to end up with this table-like structure here at the bottom where we assign these columns to properties, and then we'll be able to invoke them. So rather than hard coding now, we can use this data source, which in our case is randomly generated by SoapUI itself. And we're going to need to kind of get into our data of this project, right? And we'll use this tool called Get Data to do that. So we can right-click on our property fields here, or we can use the button on the side. And this is yet another way that we can circumvent this scripting and parsing through data objects now. Essentially what we're doing is looking at our project on that large scale and mapping these values. So I can go into my data source. If I needed to, I could reach across test suites for certain values. I can reach across test cases. I even have the ability to reach into a response, right? So say maybe I had a previous response that had some information I needed. I'd be able to come and grab that here and pass that along from step to step and really get that functional workflow going. But in this case, let's grab from our data source and grab the city. And you'll see that now we're hitting Stockton, which is actually the last value on our table. In order to start making this loop, we need to connect to our data source and start off on our request, our first request here. Now, alongside dynamically generating properties here within our request itself, we also have the option to use this Get Data tool in other places. We're going to be able to use it here in our assertions and even in our Groovy scripting as well. So I could remove this hard-coded value of Stockton and pull to that data source again, right, to double-check the response. So now I'm sending Stockton. I expect to see Stockton in return, right? And now I'll have a validation for that. That's going to change whenever we go through the next iteration of our data source. So that's how we're creating this reusable test here, right? We're bringing in these large data sets. Now we're creating these dynamic pathways rather than hard coding values. So we can go over large sets of data and make all these complex validations against it and see how our API is responding, and then start to get that feedback that we're looking for when that iteration is completed. And that kind of brings us into the manual fashion in which we're going to review our test. Before we get into automation, it's important to know, kind of the first steps, looking at details and things like that. We'll look at our transaction log. And here I can, see sort by unknown. Maybe I don't have enough assertions on things. Those will show up as unknown if we don't have any pass-fail validations. I can sort by failures here, and we'll take a look at exactly what went wrong with our Google Maps request. And I have a hunch that it's going to be in relation to our SLA assertion, right? Because we had a deal with Google of 200 milliseconds, and they have not delivered, apparently. So we can come and take a look at our transaction, view the raw data here. Obviously, there's nothing wrong here with this. But we'll take a look at our messages, and depending on the specificity of our validations, we'll see exactly what happened here. From there, we might want to get this information to other people. We can manually export this data as granular as we need to keep it lightweight in XML or CSV. We can create JUnit reports manually here. And we can create a printable report as well, which is going to come out in a PDF format. This is the really human consumable version of what we're seeing here in our transaction log. We'll get our test composition. We'll be able to view that transaction log in the message stacks. And importantly, we'll get this raw information in the message stack in here as well for the people who are going to need that. So we'll be able to send that out manually however we need to if we happen to be in the tool working, right? But the real end game is getting into automating this. Let's say we've totally configured this great functional workflow. We're passing values along. We have a reusable test. We're data driving it and getting all this great information back from our validations. It's more increasingly popular to be plugging these types of things into CI/CD workflows these days. And we have a couple different options here. There are some direct integrations, and these are growing every day with things like Jenkins, right? We'll have a native integration there, HPALM, and Microsoft or Azure Cloud, for instance, right? You'll be able to come and find these in the integrations tab, and I encourage folks to check that out. We'll have direct links to documentation on how to set those things up here. But if there isn't a native integration, or perhaps you're just more comfortable getting a little more granular and configuring everything yourself, we can use the test runner, which is essentially what all those plugins are using anyway. Except now we'll have the ability to come within the tool and configure this command line output. And that's how we remain CI/CD agnostic with SoapUI Pro, is by generating this command line. And we can put in different arguments like our test suite, our test case. We'll configure file paths and things like that. Even change environments based on what we set up in our environments menu here, which will essentially allow us to change our URLs, our endpoints, databases based on which environment we're using, then change it on the fly within the tool, or select it here within our automation options, depending on which environment we're testing in. We'll configure our reports here. We can even set up custom tags per test case or test suite. Say we have something like regression, we have a few that we want to test, a few that we don't. For that particular test run, we're going to be able to invoke that in our command line here. And what we end up with is this generated command line for us that we can insert into any CI/CD tool that we want to use, right? This could be a scheduler on our machine. This could be plugged into Jenkins via Jenkins file or via Jenkins interface. We can use this in Bamboo, etc. Pretty much every tool that's going to run command line is going to be able to use this. And all we have to do is make sure we have an installation of ReadyAPI on whatever machine's going to be running the tests, as well as our project file. And we're going to point to this batch or shell file, depending on our operating system. So that's really our journey here, from bringing in APIs in multiple forms to starting to set validations, interacting with our response directly, and making validations on that, to bringing it from a simple unit test to a reusable data-driven test, looking at the results, and then taking all that information and plugging this into our automation pipeline with SoapUI to get started on our API testing.
That was awesome. Thank you so much, Russell.
Absolutely.
We definitely, there's a couple questions here.
Oh, yeah.
So let's go through. One of the first ones is, well, will you be sending out the recorded video? And we definitely will. So be on the lookout probably Monday or Tuesday for that video. Next one, can you mix SOAP and REST definitions and testing within the same project?
Yes, you can, actually. So the project scope is it's basically the global scope for something. But if, say, we had, I think I actually have an example here of an e-commerce test suite
for a SOAP response.
Yeah, where I've brought in a SOAP. I have a SOAP API that I'm interacting with for this particular application, let's call it, and a REST API. So I'm actually be able to put those under the same project umbrella with no problem.
All right, awesome. Does ReadyAPI support the validation of JSON body either in the request or response of the Swagger OpenAPI spec, which I actually think we went through, which is pretty awesome. So the answer to that is pretty much yes, correct?
Yes. Yeah. So we'll get that body back in our outline tab, right? Or see it as JSON, XML, or raw data. But with the outline, it breaks it down into something we can interact with directly and make assertions against that body.
All right. Let's see. So there's a question about CI/CD and license. Do you have to purchase a separate SoapUI Pro license to run on the CI/CD server, or can you use the same license that you use to develop tests with?
So that really depends on the setup itself, right? There's two types of licenses. Basically, there's a fixed license, which is one user, one machine. And then there's floating licenses, which can either be used for multiple users, right? With one concurrent user at a time. You know, maybe people only use it so many hours a week, and you've got 4 people switching up between time. The other instance of using that floating license would be for something like Jenkins slaves, right? Or using Docker, where we're creating instances and then tearing them down. Where we would normally lose a fixed license, a floating license actually lives on a server outside of that instance and communicates only when these instances are spinning up. So typically a floating license is the way to go. Whether that's going to be a separate one from the one you used to develop or not really comes down to how often you're doing the testing. If you're going to be running the testing, while you're deving or working on these tests. I think my computer just died, but that's okay. Yeah, so that really comes down to that. So you could get a fixed license for your work, get a floating license for your Jenkins slaves or servers or what have you. That totally comes up to user preference.
All right. There's a couple integration questions. Definitely all of our integrations come with a license, so you'll be able to integrate with, let's say, the Jira or Jenkins natively without actually having to purchase anything else. For Jira, you'll just have to have an Atlassian license on the other side. All right, there. 1 or 2. Do you have an example on passing all the test results to a CSV or XML file? We might have an example, but we definitely can pass to CSV, JUnit, XML, HTML. We have really robust reporting, and we can also dump all of that into your CI tool as well. So if you are using Jenkins for your reporting, you can kick off your tests with Jenkins on ReadyAPI. We'll also dump out all the logs and all of your results right into your Jenkins console.
Yeah. And if you're reviewing the video later, you can go back to when we were manually creating a report, and you'll see when we're creating these XML or CSV exports or our JUnit exports, there's actually a location where we're going to set the file location to be able to go find that if we're doing it manually as well.
All right, last question. Is there a sample REST service? So there's definitely a couple sample projects in ReadyAPI when you download it. Most of the sample projects will actually use a virtual service. So it'll start up a virtual service created by Service vPro, which you can test against. But as SmartBear, I think we can always say, head on over to petstore.swagger.io and check out that as far as a live RESTful API that you can start doing some examples against. All right, if there's any major questions in here, we will put this back with the email. Thank you so much for attending, and thank you, Russell, again, for showing us that demo. Hope everyone has a good day.